from here. Yeah, so you're trying to find the partial of f with respect to what? U. That's the first one it asks you for, because we need to do u. So that's going to be partial f with respect to x times partial x with respect to u plus partial f with respect to y times partial y with respect to, exactly, I like that, it's a lot better. Good. Okay, so can we do df?
We have f of x up the chart.
Yeah.
F sub x, I mean.
We have f sub x?
Yeah. Of 1, 2 is 2.
Yeah, f sub x of 1, 2 is 2. So know that we wanted it 2. So we want df, hold on, let me just do this. df du at what point? 1, 2. And the reason we're doing that in this part here, let's move this over here. We're doing this. This is the important thing. We're doing that because we know that dg du, sorry, delta at 0, 0 is the same thing as df du at 1, 2, which is going to be 2 times df, thank you. Yes, I am. No, df du. So this right here is right there. That's the 2. So how do we get the dx du? What do we actually have to do a derivative, right? Dx du, that's what? What's dx du? What? Say it again. Do you agree with that? If so, state it. Okay, great. So it's e to the what?
0.
Why is it 0?
Because u is 0.
Mm-hmm. Plus df dy at, so fx, what is it?
5.
5, thank you, times
E to the 0.
du is e to the u again, but you're plugging in that. So you end up with 2 plus 5 is 7. Yeah, much better. I like that. That's clean.
Where did we get that u equals 0?
We got u equals 0. We skipped a little step there. In this case, the partial of y with respect to u is going to be equal to e to the u.
Yeah.
But what are we saying right here? We're saying that u is equal to 0 and v is equal to 0. And that's the same thing when x is equal to 1 and y is equal to 2. That's the same thing. Yes?
It also wants us to find with respect to v, if you want to go on.
Yeah, we don't need to do it again. It's just, is it very, very, very similar?
It's just using cosine and sine instead of
Yes.
e to the u.
And is it, yeah. Does it come out nicely?
Yeah.
Good. Do it again, right?
That should be d squared too.
Thank you. Actually, no,
squared.
dt squared. Yeah, like that. So what's going to get kicked out again? The same thing.
A.
Do we have to use the product rule? No. So what's it going to turn into? F prime of u minus, actually what's it going to turn into?
A plus.
Plus a squared g double prime of
V.
v. So did we actually just figure out the left side of this equation? Did we? Yeah, we just did. We just did the left side. We didn't touch the right side. The right side tells us to do the partial with respect to x. The partial with respect to x. Not x, the partial with respect to x, right? And does it work really nicely? Do you see it? Yeah, so when you do the first one, when you do dx of this thing, you're going to end up with f prime of u. Do you have to pop anything out? No, what's the derivative of that with respect to 1? You popped out a 1, and then it's going to be plus what? G prime of u, correct?
G prime of v.
G prime of v. See? At least I predicted the problems, right? So then what's it going to be when you take the second one? Are we going to? Yeah, is anything new going to pop out? No. You're just going to have f double prime of u plus g double prime of v.
But if you factor the a squared out of the
Yeah,
top,
and this is
you
equal
multiply
to
the f squared at the bottom.
a squared times d, not d, delta partial, second partial z time over partial x squared. So is that what we wanted to show?
Yep.
Yeah, we're done. Good.
Can I go fill my water?
Go right ahead. Sure.
Yep.
Yeah. Mm-hmm.